All right, folks, what we're going to do in this lesson is we are going to learn about or review, you may have already learned about it, what are called composition functions. Now, I'm going to focus on composition functions as they pertain to calculus because this is a pre-calculus class. And so I'm going to focus on composition functions, explaining them to you in three ways. Analytically, which is where you're actually dealing with the analytical algebraic expression or expressions themselves. Then numerically, that's where I just kind of give you the numerical answer without knowing what the function is. And the third way we're going to focus on it is graphically. So we're going to look at some graphs of functions and see how they become composition functions together. Okay. So what is a composition function? Well, the idea of a composition function is the idea that, a function is a situation where you have an input variable that, when processed, gives you some kind of output variable. So, for example, let's say you earn $10 an hour. Let's say you have a job and you earn $10 an hour, and the input is number of hours that you work, okay? And the output is how much you earn in your paycheck. So let's say in a 2-week period, you work 73 hours, and then the function goes like this, that you multiply that by $10, and that gives you $730, okay? And so the function for this would be that the output, which is your P paycheck, is equal to $10 times H number of hours. So this is a linear function here. The output is P, the input is H, okay? And so a composition function is a situation where the output of one function becomes the input of, I'm going to put sub B here. Okay, so the input of function A produces an output of function A, and then that number then becomes the input in another process, right? So, for example, if we wanted to know how much taxes you're paying from working 73 hours, you would have to take your paycheck, which is $730. So the input into, well, let's say how much you're going to pay in Social Security and what's that go along with? It's FICA and Medicare, okay? Typically, you're multiplying that by 7.625. So input times 0.0, that's percent, 0.76 or 0.765, I think, and I can't remember what it is. Something, it's around 0.07 something. And that's going to give you your output, which is taxes, okay? And so if you multiply your $730, okay, times 0.0765, this is going to tell you how much you are going to have to pay in Social Security tax and Medicare tax. So 730 times 0.0765, that's going to be $55.85. All right? And so here's what I'm saying, is the amount of money you earn is a function of how many hours you work. But the amount of money you pay in taxes is a function of how much money you earned. And so what we can do is we can actually skip over the money earned step, and we can say that the amount of taxes you pay is the result of how many hours you work. And this would be a composition function. We know that the tax is going to be 0.0765 times your paycheck, which is going to be equal to your taxes are going to be equal to 0.0765 times P. And what we can do is we can take this function, the taxes function, where your paycheck is the input, and we can take your paycheck function where your hours are your input and your paycheck is your output, and we can turn them into one function. We can take the P out and put in what P is equal to, and what we'll now have is that your taxes are equal to 0.0765 times what your paycheck is equal to, which is 10 times your hours. And what we now have is we have taxes as a function of hours worked. This is a composition function. We put one function in for a variable in another function, and we make a new function where taxes are now determined by the input of hours. Okay, so we're skipping a step of calculation. That is the idea of a composition function. And so what I'm going to do now is I'm going to explain to you how you can create composition functions and what the notation looks like. Okay, so let's go ahead and jump right into that. All right, so I give you all these functions over here, and you can see that f of x is simply it's a function of x, and it is 7x minus 3. That's a linear function. G of x is a quadratic function, x squared minus 4x minus 7. H of x is equal to e to the x power. Remember that e is the exponential base of continual exponential growth. Okay, it's approximately equal to 2.71828. K of x is equal to sine of x, so it is a trigonometric function, okay, where x is the input angle measure, okay? And so let me show you what one way of writing composition functions. There's an older way that I do not use, and I'm not going to even write it up on the board, but it is basically where you do f of g, and it's like an f, then a little o, and then a g. It looks like fog, okay, and it's not fog, it's f of g. I have a different way of writing f of g that makes a lot more sense to me. I've noticed that the FOG method tends to confuse a lot of students. That doesn't mean that my method won't confuse students, but I'm going to use a method that I think is a little easier to understand. So let's say that I want to identify f of k of x. And here's what I'm showing you, all right? Instead of having an x here, instead of having f of x, we're replacing x with a whole nother function. We are putting the k of x function, which is sine of x, in the place of the x in f of x. And since f of x is equal to 7x minus 3, what we would do is we would then replace, in the function, we would replace the x with the whole function k of x. And so instead of 7x minus 3, what we'll have is 7k of x minus 3. Okay? So in the place of the x, we'll put whatever k of x is equal to. So now we'll say that f of k of x is equal to 7 times, now instead of putting k of x here, we're going to put what k of x is, which is sine of x. So we're going to put a sine of x in here, minus 3. Okay? And this now is the composition function f of k of x. You can also write it as, since there's no distribution necessary, you can just write 7 sine of x minus 3, which now you may recognize as a sine function that has a vertical shift of -3 and an amplitude of 7, right? All right, so let's try another one. Let's say we wanted to identify g of h of x. So g of h of x, okay? Now, g of x has 2 x's in it. And so what we're going to have to do is we're going to have to replace both x's with h of x. And so instead of writing x squared, we're going to write in parentheses, we're going to put h of x in parentheses, and then we're going to square it. Okay, so we have h of x squared minus 4x, but instead of 4x, so minus 4, and instead of an x, in place of the x, we're going to put h of x. All right, and then minus 7. There's no x's there, so we just put it as minus 7. Okay, and now what we're going to do is we are going to replace every instance. Well, we'll leave h of x here, g of h of x. Each of these instances of h of x we're going to replace with e to the x power. And so we're going to put in parentheses e to the x power and then square it minus 4 e to the x power and then a minus 7. Okay? And so this is the composition function g of h of x. Okay? Now you could simplify this. E to the x power squared, in this case, you would, this is e to the x times e to the x, and you know that e to the x, whenever you multiply a common base, you can add together the exponents, so it would be e to the 2x. So this would be the same thing as e to the 2x, okay, minus, we don't need these parentheses because there's nothing to distribute, 4e to the x, and then minus 7, okay? And here is your composition function, g of h of x. Okay. All right, let's try another one. How about h of f of x? H of f of x. Here's what I'm going to do. Why don't you consider pausing this video and see if you can write out the composition function h of f of x. All you're doing is replacing the x in the h of x function with f of x. All right, so h of x would be e to the x power. So I would put an x here, but instead of putting an x there, I'm going to put f of x. So it's e to the power of f of x, right? And you can put it in parentheses or don't put it in parentheses. But now what we're going to do is we're going to replace the f of x with whatever f of x is equal to. Well, f of x is equal to 7x minus 3. So this is going to become e to the power of 7x minus 3. Okay? Now, you could put that in parentheses. It's probably a little more convenient if you put it in parentheses. Especially if you're going to write out the answer in a computer, you would put e to the power of parenthesis 7x minus 3. And that's what your answer would look like. Okay? Composition function. We're just simply replacing the x with the function f of x, which is 7x minus 3. Okay? All right, let's try another fun one. How about f of g of x? F of g of x. All right? So what we're going to do here is f of x only has one x, so we're going to replace that x with g of x. So it's going to be 7. Instead of an x, we're just going to put g of x, right? And then minus 3. So 7x minus 3. But in place of the x, we're putting g of x. Now, when we rewrite it, f of g of x is equal to, we're going to write 7, then a parenthesis. Then we're going to put in the whole g of x function, which is x squared minus 4x minus 7. There we go. And then we're going to put a minus 3. Now, this can actually be expanded because we can distribute the 7, right? So we can go 7 times x squared. 7 times negative 4x is minus 28x. 7 times negative 7 is minus 49, and then a minus 3. And then you can just simplify this part here. Negative 49 minus 3 is minus 52. Minus 52, and then this is the composition function f of g of x. So we're turning one function or two functions into a single function. We're putting one function inside of another function. Okay? All right, let's do just a couple more examples here. Do a lot just with these 4 individual functions, right? Let's do h of k of x. H of k of x. Do you want to try this one on your own? Pause the video, give this a shot, and now I'll do it. All right, so I'm replacing x in h of x. So h of x is e to the x power e to the x, right? But instead of putting an x, I'm going to put k of x. So it's e to the power of k of x, right? We already did this with h of f of x. But now k of x is sine of x. So we can do h of k of x is e to the power of, well, k of x is sine of x. So this is e to the power of sine of x, okay? And there's our composition function. Now, these can actually become more complicated because we can actually do more than two of them. We can put one inside of another one and then put that one inside of a third one. So, for example, we can do k of h of f of x. All right, so you can see here f of x is inside of h of x, and h of x is inside of k of x. Okay, now I know this looks crazy, really complicated, but here's what I want you to understand. Here's what we're going to do. We're going to write out k, which is sine of x, but in place of the x, we're going to put h of f of x. We're going to put a composition function in place of the x. You see that? And now we can write it again, sine of, now we can put h here. Well, h of f of x is going to be h of x, e to the x power, but in place of the x, we'll put f of x. So it'll be e to the power of f of x. There we go. And now we can replace f of x, we'll put sine of e to the power of, but instead of writing the letters f and the parentheses in the x, instead of writing f of x, we're going to write what f of x is, which is 7x minus 3. And so now we have sine of e to the power of 7x minus 3. And here's what I want you to know is that in calculus, so k of h of f of x, okay, is equal to this thing. It is not terribly uncommon in many calculus classes for you to see a question on a test that asks you to do something with a function that looks like this, okay? So one of the things that I'm trying to do in this lesson is I'm trying to expose you to the idea of seeing different kinds of functions intermingled with each other. Okay, because if the first time you see it is when you get into your calculus class, you could freak out and go running for the hills. Okay, don't do that. Trust me, this is not as big of a deal as you think it is. The more that you see these, the more comfortable you will be with them. Okay, now we could totally switch the same three functions up, and we could do, how about f of k of h of x. All right, do you want to try this one on your own? Pause the video, see if you can figure this one out. All right, so the main function is f of x, so that's 7x minus 3, okay? 7x minus 3, but instead of the x, we're going to put here, we're going to put k of h of x, right? Okay, well, what is k of h of x? Well, k is sine of x, so that's 7 times sine of, but instead of an x here, we're going to put h of x. Okay, minus 3, and so that'll be 7 times sine of, okay, well, what is h of x? That's e to the x power. We'll just put e to the x power here, and then minus 3. So it's 7 times sine of e to the x power, quantity, minus 3. Okay, this is f of k of h of x. Let's do maybe one more before I show you the next kind of composition function. Let's say that we did g of f of x. So we did f of g of x. Now let's do g of f of x. Okay, so now previously what we did was we plugged g of x in for this x here. Now we're going to plug f of x in for this g of x here. But we have to plug it in everywhere that there's an x. We have to put 7x minus 3 here, and we have to put 7x minus 3 here. Okay? And so instead of x, we're going to put 7x minus 3. Oh, sorry, let me do the first layer. So in the place of the first x, instead of x squared, we're going to put f of x, then squared, minus 4 times x, but instead of the x, we're going to put f of x, then minus 7, right? So this is g of f of x. We've replaced the x's with f of x. Now, we'll actually put whatever f of x is inside the parentheses, which is 7x minus 3 squared minus 4 times whatever f of x is, 7x minus 3, and then minus 7. What I'm showing you here is that if there's more than one x in a function, then if you're plugging in another function for x, you have to put that function in every single place that you see an x in that function. Now, it could be left like this. That's totally fine. But additionally, you could expand it. So 7x minus 3 squared would become 7x times 7x. That's 49x squared. Negative 3 times 7x is minus 21x. Then 7x times negative 3, another minus 21x. Negative 3 times negative 3 is plus 9. Coming over here, negative 4 times 7x is minus 28x. Negative 4 times negative 3 is plus 12. And then finally, minus 7. And then this can be simplified to 49x squared minus 21x minus 21x minus 28x. That's negative 42 minus 28. That's negative 70 minus 70x. Plus 9 plus 12, that's 21. Minus 7 is plus 14. And so now what you are looking at here is, this is the composition function g of f of x. Okay? All right. So now what I want to do is I want to move to another kind of composition function, which I actually consider to be a little bit easier than this. And this is where you are told that there's a new function. Let's say, for example, v of x. And so they're going to tell you that v of x is equal to 2 or more of these functions that are multiplied by each other or added to each other or subtracted. So, for example, let's say that v of x is equal to f of x plus g of x. Okay? Now note that it's not one inside of another, it's simply one being added to another. We are composing v of x of f of x and g of x. And so here's what we're going to do. What's v of x now going to be equal to? Well, v of x is going to be equal to whatever f of x is, which is 7x minus 3, right? We can put that in parentheses, plus whatever g of x is. Well, g of x is x squared minus 4x minus 7. And now what we can do is we can find v of x by adding these two together, okay? So that's 7x minus 3 plus x squared minus 4x minus 7. Now we can combine like terms. We've got an x squared. That's dealt with. 7x minus 4x is plus 3x. Good. And negative 3 negative 3 minus 7, dealt with these, sorry. Negative 3 minus 7, that's minus 10. And so now v of x becomes this function, this quadratic, x squared plus 3x minus 10. Okay? All right. We can also do other crazy things, like let's say that p of x, let's say that p of x is equal to 2x plus 3 times f of x. You see this? So, p of x has its own, like, linear term here, 2x, okay? And then we're adding to that f of x multiplied by 3. And so what we would do here is we would do p of x is equal to 2x plus 3 times whatever f of x is, which is 7x minus 3. Now we can just distribute 2x plus 3 times 7x is 21x. 3 times negative 3 is negative 9. Now we can combine like terms here, and we get 23x minus 9. So p of x is equal to 23x minus 9. Okay? We we made p of x out of some components plus a scaling up of f of x. All right. We can also, let's say we've got I don't know. Let's try r of x. Let's say that r of x is equal to how about g of x over h of x times k of x. All right, so we've got a division here with a multiplication in the bottom. And so r of x would be equal to x squared minus 4x minus 7 over h of x, which is e to the x power, times k of x, which is sine of x. And so this is now your composition function. All you had to do was just put g of x in the top and then put h of x times k of x in the bottom, and this is now r of x. Okay? Now, why do we do this? Why do we use composition functions? Well, in the world of math, there is a lot of what we call substitution. We solve for one thing, and then we put it in to something else. But sometimes we want to know what it looks like before we solve. Here's a very common thing that you might see in higher, kind of medium to higher level math. You might see, let's say we have an area formula. The area of a circle is, let's say, it's pi r squared, okay? But then let's say that the radius of the circle, okay, is a function of x. Let's say that r is a function of x, and it's equal to g of x minus f of x. So the radius is now related to the variable x, and the way that the radius is related to the variable x is it's the function g of x minus f of x. Okay, well now the radius is going to be x squared minus 4x minus 7 minus 7x minus 3. And so now the radius becomes x squared minus 4x minus 7, right? Now we got to distribute this negative. Minus 7x is minus 7x, and minus negative 3 is plus 3. And now we can combine like terms. X squared minus 4x minus 7x is minus 11x. Negative 7 plus 3 is minus 4. The radius is now x squared minus 11x minus 4. And so what we can do here is we can now represent area as a function of x, which is pi times x squared. We're replacing the radius with what the radius is equal to. X squared minus 11x minus 4. Then we have to square it because the area formula is pi r squared. This is not terribly uncommon in when you get into calculus and into higher levels beyond calculus. Okay, so this idea of substituting for a variable with a whole nother function is a normal thing, and you have to get your brain used to it. So what I'm doing in this lesson is I'm introducing it to you, and I'm going to give you easier circumstances so that you can work on the easy stuff. That way later in your math career, you'll be able to do this with much more skill, and it'll be much easier for you. Okay? All right, so this is analytical composition functions. I don't think I'm going to go any farther than what I've shown you in this particular segment, but what we are going to do now is the next segment that we're moving into is we're going to do numerical examples where you calculate the output of a composition function being given output variables or output values from other functions.